What if the universe has a drain and a faucet? You already know about black holes, the cosmic vacuum cleaners that pull everything in and never let anything escape. But here's what nobody talks about enough. Physics says there must be something on the other side. Something that doesn't swallow matter, it violently spits it out. Scientists call it a white hole. And the terrifying part? The math says it's real. But we've never actually seen one. Or have we? Stop scrolling. Because what you're about to hear will completely change how you think about space, time, and the universe itself. Let's go back to basics. In 1916, Carl Schwarzschild solved Einstein's equations of general relativity. His solution described what we now call a black hole, a point in space where gravity becomes so extreme that nothing, not even light traveling at 299,792 kilometers per second, can escape. That's settled science. We've even photographed one. In 2019, the Event Horizon Telescope captured the first real image of a black hole, the supermassive monster at the center of galaxy M87, clocking in at 6.5 billion times the mass of our Sun. But here's what the textbooks skim over. Those same Einstein equations that predict black holes also predict their mathematical opposite. A white hole. Same equations. Same physics. Mirror result. A region of space where matter can only come out, never go in. Think about that. A place in the universe that physically cannot be entered, but endlessly pours out energy, radiation, and matter. It doesn't attract. It repels. While a black hole is the ultimate sink, a white hole is the ultimate source. Now, before you think this is science fiction, hold on. Because the math isn't science fiction. The Kruskal-Zucker's coordinates, developed in the 1960s, extended the Schwarzschild solution and revealed that if black holes exist mathematically, so must white holes. They're not separate objects. They're two ends of the same theoretical structure called the Einstein-Rosen bridge, what most people casually call a wormhole. A black hole on one end, a white hole on the other, connected through space-time itself. This came directly from peer-reviewed, accepted physics, not speculation. Here's where it gets controversial. In 2006, a gamma-ray burst was detected, cataloged as GRB 060614. It didn't fit any known model. It lasted 102 seconds, far too long for its type, released enormous energy, and left no trace of a supernova, which should have followed. Some scientists quietly asked the forbidden question: could this have been a white hole? The data was never conclusively explained. NASA confirmed the anomaly. The debate never fully closed. Then in 2014, physicist Carlo Rovelli, one of the founders of loop quantum gravity, published a paper in Physical Review Letters suggesting that black holes don't simply collapse forever. His model proposed that after an incredibly long time, a black hole could quantum tunnel and transform into a white hole. This isn't fringe science. Rovelli is one of the most respected physicists alive. His paper passed peer review and triggered a wave of follow-up research that continues today. Now here's the part that should genuinely unsettle you. If white holes exist and eject matter, where does that matter come from? One possibility, and this is where established cosmological theory gets wild, is the Big Bang itself. Some researchers, including physicist Lee Smolin, have proposed that our entire observable universe, everything you see, everything that exists, every galaxy, every star, every atom in your body, could have emerged from a white hole. That the Big Bang was not a beginning of everything, but rather the output end of a black hole somewhere in a parent universe. This is an accepted consensus, but it is serious, published, peer-reviewed theoretical physics. Here's the retention breaker nobody mentions. White holes, by their very nature, are unstable. According to general relativity, if a single particle of matter attempted to approach a white hole from outside, the interaction would theoretically cause it to collapse almost instantly into a black hole. Their existence window might be so brief that detecting one would require being in exactly the right place at exactly the right moment in cosmic time. We might have already missed thousands of them. Or we might be looking at evidence right now and calling it something else. The James Webb Space Telescope, launched in December 2021, is currently observing the earliest light in the universe with unprecedented resolution. Astronomers are identifying unusual high-energy events, anomalous galaxy formations, and unexplained brightness signatures that existing models struggle to categorize. While nothing has been officially labeled a white hole, the data being collected is actively challenging what we thought we understood about how the early universe formed and released energy. Science works by eliminating what's impossible until only the possible remains. White holes haven't been eliminated. They've been mathematically confirmed, theoretically expanded, observationally hinted at, and taken seriously by the world's leading physicists. The only thing missing is direct, undeniable confirmation. And in the history of science, the gap between theoretical prediction and confirmed discovery has closed before. Gravitational waves were predicted in 1916 and detected in 2015. We are living in the age where the impossible keeps becoming real. Follow this page right now, because we go deep into the questions that most channels are afraid to touch. The universe is stranger than you were ever taught, and we're just getting started. Now here's the question I want you to answer in the comments. If white holes are real and the Big Bang was one of them, does that mean something created our universe on purpose? Or does it make creation even more random than we feared?